everyone. I'll just pretend we're plenty. Welcome to Android. We are going to have multi-threading and networking and RX Java and Retrofit, and then some career advice towards the end of the session. So first things first, the list of things I was to talk about had like that I should give a bit of intro about myself, how I got started and how I got into tech and how I started programming for Android. So I'll do that briefly. I studied computer science at OAU, Obafemi Awolowo University. And while it wasn't the course itself that made me start programming, I had friends who knew how to build apps. At like 100 level, they were already building apps to work on Android Symbian phones, J2ME, Java. And it looked fascinating at the time because I'd never seen anyone do it. So I forced them to teach me, sort of bullied, but I got them to teach me. And while I didn't exactly know what I was doing, I knew that I was building an app. So we had all these drag and drop things in NetBeans, sort of like the navigation components, where you drag and drop views. And then I think my class had about 10,000 lines. And then my DB was just one long line of people's names. Anyways, long story short, the code was horrible, but the app worked. Of course, no test, no architecture. I didn't even know what all that was. And as I started playing, that was my first ever intro to programming. And I did that and got exposed to more things. We had a really active GDG. And we're all young and hungry and eager to learn and eager to share knowledge. So by the time we did all of that, plus a couple of more years, I was introduced to front-end development and then Android development. And I liked Android. I think at the time, the promise of building apps for so many smartphones was very interesting. And the idea that everybody could have your app on their phones looked very interesting. So I stuck with Android. And it wasn't really easy because when I started, I was using a Windows laptop, and I didn't even start with Android Studio. I started with Eclipse, where you didn't have to import into Gradle. To import a library, you had to have a Java file and some one R.java class that was always disappearing. So you always had to restart Eclipse to get it to come on. It wasn't as smooth as it is now, but you know, I kept at it and then took a couple of online courses, developing Android apps on Udacity. And because of all my community work, by the time I was leaving school, I got the ticket to attend Google I/O. And that was where I met my first boss, who gave me my first job before NYSC. So I got into my first job, and 1 month later, I signed up for the nano degree, the Udacity nano degree. I did that for 6 months, and I also did my NYC at that current job. So immediately I left. After NYC, I got another job, which allowed me to work remotely. And I was like the first employee from Nigeria. So I did that for almost 3 years. And now I am currently in between jobs and hopefully to resume at a new place soon. For the Google Developer Expert journey, I think it had to do with all my community work right from when I was in school. So even though community organizing doesn't really count, it's your like technical contributions, your talks, your articles, open source contributions, that counts towards it. But because I was already on the right path, people sort of knew me because of my community organization. And then when I would travel for all these conferences, IO and all the rest, GDG summits, I tend to like network with people and then stay in touch. So by the time it was ready for me, like by the time it was time for me to interview, I didn't have any trouble getting someone to recommend me to become a GDE. That was the first time, which I failed the interview. And then the next year I was recommended again, and then I passed, and here we are. This picture was from my second Google I/O. 16. All right, so let's get down into business. Multi-threading with RX Java. Before we go on, I'm assuming that you'd have had some brief intro to RX. You understand at least the very basic concepts of what multi-threading is. And I'm not going to go into what observables are or what subscribers are. I'll just like go on based on the fact that you have basic knowledge of this and then try to build on that. So I decided to start from the beginning just to make sure that the foundation is solid. So Android has 4 basic components: activities, services, content providers, and broadcast receivers. I put the fragment there, not because it's a component, but because in this context, it's very close to the activity, like in this multi-threading context. So I felt it was best for us to put it there. And I'm sure you'd have already had experience with activities and fragments, so it won't be too strange to you. So the gist, why I brought all this is like all this run on the main thread. Like any activity that wants to happen in all these four components happens on the UI main thread, which is how Android is configured. So how does the main thread like now delegate it? There is a queue. I don't know if you know what queues are. It's a data structure that allows items to come in like first in, first out. So imagine you're on a bank queue. The first person to go there is the first person that gets attended to, is the first person that leaves. So that's how a queue works, but like it's a data structure. And there's something called the message queue that the UI main thread uses to process work that all these 4 components decides it wants to do. So I put the arrow there to show the direction of our queue, and then here we have like the activity first, service next, broadcast receiver, content provider, and then based on whichever new job needs to be run, it gets added to the queue in the order of time in which it was created. All right, but the thing is, Android has this funny way of updating the UI where it refreshes the UI 60 times in 1 second. I'm not sure if you've heard of like 60 frames per second mentioned anywhere. Well, Android has refreshes, if you don't know, it refreshes your thing 60 times in 1 second. But for this to happen 60 times, it means that each activity must not exceed 16 milliseconds to run. So every activity in the queue must be complete by 16 milliseconds. It might not use up to that, but it must be complete before 16 milliseconds. So for each of these jobs put there by each of the components, I just put like estimate of times. The 16 is yellow just to show that indicates like a warning sign that we're approaching our boundary. All right, so what happens when we exceed 16 milliseconds? I'm sure you would have noticed when you're, say, using an Android app, and then the screen doesn't respond for about 5 seconds when you tap it. So what's happening in the background is that some activity has exceeded that specific time. So some frames are dropped. Like instead of it to update, let's say we need 60 frames in 1 second. Now we only get like 58 frames because we've dropped 2 frames because some activity was taking too long. And that's what's called jank. You might not have come across that word, but that's what it means. That's how it happens in Android. And all this is because some activity has exceeded the 16 millisecond maximum running time it should have. So what are the common causes? If you do I/O operations like network requests, you are making network requests on the main thread, or you're accessing your database, room, SQLite, Realm, whatever it is. If you are doing that on the main thread, you're going to have jank because network requests, I/O operations take time. So I/O operations are not just network requests, they can also be like database access locally. Those take time, and then another common cause might be long calculations. Say you're converting, you're like doing some image conversion, or there are some heavy image processing things people do. Let's say to convert your image from color to black and white, and then you're doing all that on the main thread. That might not take a lot of time, but it's CPU intensive and it uses a lot of resources, so it would also block the main thread. And if it becomes too extreme, then you might see this dialogue. Your app is not responding. Close up or wait. I'm sure you might have seen this on some apps before. But if you've not seen it, all this that I just explained is the background cause that eventually leads to this. So why is this important to us? I think as Android developers, we should all be advocates of good user experience who are like using our app, and of course this will result in higher ratings for the app. Sometimes you might get some reviews that like the app is too slow or it's hanging, and so it's all this junk, and then the ANR error that causes it. And then higher revenue for the app. If you need people to pay for your app, they only want to pay for something they have a pleasant experience using. And then higher retention. If I open an app and it crashes too much or it hangs too much, I personally won't go back to use the app. So the only way you can get more users is to ensure that the experience is good from the beginning. And this is one very huge way of ensuring that happens. And so we've talked about the problem, we've talked about how it impacts us. And now we are going to explore different solutions. So this is like built for Android development. And I'm not sure if you came across this during your lessons. Yeah, you have 3 methods. I can't remember what they're called. Like before, like there's before, there's an in progress, and then there's, yeah, when it's complete, and then you can do different things based on what stage the method is in. But there are 2 huge problems with this. You can't cancel a task. It's impossible to cancel a task. So imagine you start something in your async task, and then you rotate your screen, the most popular Android problem, and then your activities are recreated. But this is still, your async task is still running because you did not cancel it. And then by the time you're giving results, you are referencing views that have already been destroyed. So that will result in memory leaks and crashes. The next potential solution, which is built for Kotlin, is using coroutines. But coroutines are like kind of like lightweight threads that you can use to switch between threads. But unfortunately, this stuff was supposed to be built for Java, although I still snuck some Kotlin into it, but that's not, coroutines are not why we're here today, so maybe some other time. All right, so back to why we're here. RxJava is a very popular open source library, and it's interesting that the history of RxJava started from not RxJava, Rx in particular started from Netflix, I think, with some .NET. It started in .NET, and then as the developers were leaving Netflix, they were carrying those solutions to their various companies. Is it .NET or JS? I can't remember exactly. So like people left Netflix to go to Microsoft, and then I think there was RX.NET, and then people left Netflix, and all the developers who left found a way to create other language specifications of the reactive framework. And so this is the definition from the website, JVM implementation of the library for asynchronous and event-based programs by using observable instances. So an interesting thing about this is that asynchronous doesn't mean that it operates off the UI thread by default. So it operates in the thread that the observable operates in if you don't switch threads. I don't know if that makes sense. Like if you use RxJava and you don't specify that it should switch to another thread, it's going to operate on that particular thread that you called it on. So if you call it from the main thread, it's not going to switch its thread by default, except you specify that you want the operation to happen in a different thread. All right, so I was going to make this slide, and I was looking for the best way to depict what subscribers and observables do. And I did a bit of Googling, and this, I think, in my opinion, is the best way I can depict it with an image and a GIF. So I don't know if you're familiar with Pac-Man. Yeah, so you know that it can only eat the blue ghost when the dot is blinking. So the subscriber is sort of like the consumer of the observables, which is obvious from the image, I hope. And then the observables emit items but it only emits when there's a subscriber to consume them. But the only way new items get emitted is when you enter subscriber.onNext. When you type the onNext method of the subscriber. So in this case, what it is showing is that there was a subscriber.next, then a new ghost appeared, waiting for the subscriber to consume. I was supposed to get in touch with a UI person to help me. Yeah, so I'll have a button, and then when I click on next, the ghost enters the mouth of the Pacman. But this is, I hope this makes sense. This is how best I thought it would be easier to explain. So how does that happen? How does RX schedule, how does RX do multithreading? So it makes use of things called schedulers. And these are arbitrary blocks of code. This executes blocks of code possibly in the future. But how does this happen exactly? So internally, there are workers. So you can't interact with the other threads directly. You have to go through schedulers. And schedulers internally create a worker for that particular thread anytime you call it, depending on which of the methods you call. It might not make sense now, but I have explanations as we're going forward. And how does this do this? How does it do this? It does it with the aid of two methods: subscribe on and observe on. So if you, let's say we have an Android app that we want to connect to the internet, and of course, we're not supposed to make that kind of long-running call on the main thread. So we'll subscribe to the observer on a particular thread. And then by the time the result comes out, because in Android, you can't display UI work on a different thread. It has to be on the main thread. So you have to observe the results on another thread, which is why we need observe on for Android. And the combination of these three is how you switch between threads in RX Java. And so there are a couple of observers, there are about 8, but I'm only going to touch on like 4 that I think will apply to you based on how much you already know. So the first is the schedulers.io. This is mainly used for IO requests, so network access, database access, you use this. And first of all, it uses an unbounded pool of threads. So this might seem like a lot, but just imagine a swimming pool with threads inside, with yarn of threads inside, and there's no limit to the amount of threads you can have in the pool. So this is kind of what this does. And then the threads are recycled. What that means is that if you use a thread and then it's idle, you're not using it at that particular time, you can use that same thread for another job. Like it gets added back into the pool. Then it's used for IO bound tasks. I've mentioned that already. And then the tasks take some time to complete. So these are not usually CPU intensive, like it doesn't require a lot of processing power, but it takes some time to complete. So it's best to switch it to the IO thread. The next is schedulers.computation. So for this, the pool of threads are bounded, meaning that you have a specific number of threads that you can use. And it's used for CPU heavy works like image processing, computation. If you have some math function that's going to require a lot of processing power, you use it. And then for this, the number of threads are limited to the number of CPU cores. So imagine like, this is a Core i3 laptop. So we know that for this, we're only going to have 3 threads. And I think the main reason it's actually bounded is because you can't have more threads than the number of cores. So since usually the number of cores is fixed, then it makes sense to have a fixed number of threads for it. All right, so this is schedulers.trampoline. It schedules tasks in the same thread. So it doesn't switch thread. I'll explain why I brought this. It schedules tasks in the same thread, and it is blocking. So it blocks the current thread, but it doesn't if there's a current task, it doesn't override it. It waits for it to finish. So it might seem like, why is when we're scheduling tasks in the same thread, right? We'll get to that soon. Don't keep that question in mind, get to it soon. All right, so very quickly, the subscribe on method. This determines the thread in which the source observable emits on. So usually source observable is like the first observable that's created, like before people actually subscribe on it or before you use any of the operators on it. and it works upstream. Only the first call counts. So if you have like 3 different subscribe on methods, if you have, let's say, observable just, and you have subscribe on IO thread, subscribe on main thread, subscribe on computation, it works upstream, meaning that the code will start from the last subscribe on, and then it will go and pick, since it's referencing the previous observable, it will go up to pick the previous one, and then go up to pick the previous one until it gets to that first observable, and it's going to execute on whatever thread that first subscribe on calls. That's what works upstream means here. So I have an example. Who can you answer the question based on the explanation?
Trade on which that observable just was called.
And so what is it? No. Okay, so I see where the gap is coming in. So immediately you call the first subscribe on, the thread switches.
You said it was upstream, and then it makes the call on the thread at the first. Okay, the IO thread. The IO thread.
Yes, the IO thread.
Sorry, it just was.
Oh, I should apologize. That means my explanation was not clear enough. So usually you have the source observable. Like you have just. That's the source of the observable. That's what source observable. Then you have the thread. So immediately there's a subscribe on, the thread switches to whatever thread is inserted. In this case, it's the IO thread. So you now have another subscribe on that's supposed to execute on computation thread. But because we said it emits upstream, so we're supposed to have code after subscribe on. So if you have maybe some map operator or something, it will first go to the subscribe on, the schedulers of computation. But because the source observable is like with the IO thread, that's when the thread first switched. It will now go back to that and then execute on that first thread. So it doesn't matter how many subscribe ons you have, it only emits on the first one where the thread was switched, if that makes sense. Okay, so back to observe on. This switches, so you might have noticed that subscribe on is called first. Observe on switches the thread to another thread after subscribe on is called. So whatever thread the current observable is on, it's going to switch it to the new thread specified in the observe on method. And this works downstream. So it's the opposite of subscribe on. So for observe on, if you have like 3 observe ons, it keeps switching the thread until it gets to the final one that is mentioned. We just go to this example to make it clearer. So like before, we have observable just hello and world. We subscribe on the IO thread. That means we are now on the IO thread. So if we try to observe on computation and then we observe on main thread, our final observable will be executed to be observed on the main thread since that's the last one that was called. But if it's the subscribe on method, it's the reverse is the case. All right, so another scheduler we have is the test scheduler. And this is a non-thread safe scheduler for testing operators that requires scheduler without introducing real concurrency and allows manually advancing the time. I have examples, but if this seems like a mouthful, it means that it doesn't switch the threads, and then it doesn't introduce real concurrency, and then it allows, so sometimes you might have an observable, say someone asks you to build an app that downloads something every 1 second. How do you do that with RxJava? Like download something, make a network request every second. And since our base is already, we're already working with RxJava, there are ways to take advantage of it to make us perform this on another thread, on the IO thread, and then do the interval thing. But because I always write code with testing in mind, so you should always think of how to test your code when you write it. They already thought that we're going to need something like this, so they provided us with the test scheduler. So this is an example of where it happens. So instead of observable.just, we have observable.interval, and then we have a constant 1 second. That's like 1,000 milliseconds, and the time minutes. So there's the subscribe on, the observe on, and then the subscribe as usual. But I highlighted that just to show us a different way to create an observable. They are different operators, but I'm not going to emphasize on that since I didn't come here to talk about how to use RxJava. I just came to mention the multi-threading part of it. So if you have a method like this, if you have an observable created like this and you want to test it, you would have to create a new test scheduler. Also, this is in common, but it should be easy to follow. So we are creating a new test scheduler object by calling the test scheduler class. So this should be like a private test scheduler is equals to new test scheduler with the parentheses. And then if you're writing unit tests, I'm not sure if you've been exposed to that, you always have a set of method. And here there are some plugins that are already made available for you. So you have the set computation scheduler handler with the test scheduler that you created. And then here, if you have a test class, for example, I grayed out the other parts because they're not important here. So this is how you use it. You call the test scheduler and then call the advanced time by 1, and then you put the time in it. I'm not sure if you noticed what's happening here. So you notice that in the first code, in the previous code, we had observable.interval 1 second. But if you call this code, like if you call this test method without the test scheduler, it's not going to run because you are waiting for something to happen in 1 second. But because we have test scheduler, we can manually advance the time so that we see the results and we don't have to wait and then the test will run. If not, the test will not pass because it's waiting for something. But using the test scheduler allows us manually advance the time so that the test would find the result of the code we're trying to run. All right, so the last scheduler I'm going to talk about today, there are many other more, but these are what I think would be relevant for you today, is the Android scheduler main thread. And it's not available in the RxJava library. It's only available in Rx Android. And it performs Android-based work on the main thread. So after all this story, I'm sure we want to know how to import RxJava. I'm sure you already know this, but I just thought to mention. So you need to import 2 things, the RxJava library and then the Rx Android library, if you are going to use the Android scheduler as the main thread. All right, so networking with Android is next. And I'm going to build on all the things I mentioned in the previous version, but it's not going to look too strange. So there are different ways to make network requests in Android, but I think for REST requests, I might add, because for GraphQL requests, you don't use Retrofit. There's another different library created for it. But for REST requests, the most pain-free way is using Retrofit. It even came recommended by Google because there's no point in creating a library if we already have one that works well. It was created by Square, and it allows us convert our HTTP API, like use HTTP API with Java or Kotlin interfaces. So you have this Java class, and then you have things specified in Java, and then Retrofit is smart enough to know based on all the inputs we give it, to make the network request and then give us our information back. And it's created by Square. So it accepts an HTTP client. It works very closely with OKHTTP, it works very closely with OKHTTP, and OKHTTP is also created by Square. And 2 of them are built to work seamlessly together. It accepts a call adapter factory. So if you're using Retrofit out of the box, if you make a network request in your service class, you're supposed to specify a call class that the network results will give you. And then you have this very huge callback method where you have, I'm sure you know what I'm talking about. You have like the callback class from the call place, and then you have this huge class of methods. But there are also other ways to bypass that, and that's by using a call adapter factory. So we have the RX Java call adapter factory created specifically for retrofits, where instead of receiving a call class back, you get back an observable, and then you act on the observable, since like that's easier to use and you don't have, it's easier to avoid callback hell with that. It also accepts a converter factory. So usually for network requests, you need to serialize and deserialize JSON. So serializing it means that the API is expecting JSON, but you have Java objects. And then when you make the request, you are receiving JSON objects, but your code is in Java or Kotlin. How do you make the switch? So Retrofit has a factory that allows you to put in a converter that you can use to like switch between the two. So if you notice sometimes that you have like camel case, let's say you have a class called weather data, for example, and it's like camel case is a class, and then it's camel case in Java. So it's like capital W, capital D. And then by the time you get into JSON, it's like weather underscore data. So I don't know if you've ever wondered how things are still able to succeed with those two different kind of names. It's the converters that make it possible for you. If not, the boilerplate you have to write manually to work on this would be a lot. So there are different kind of converters built for retrofit. There's JSON, Jackson, Moshi, Protobuf, Wire, Simple XML, and Scalars. I lifted this off the retrofit side, but I personally prefer Moshi because it doesn't mean that everybody should switch to Moshi, but it's lighter and then it doesn't use reflection. It uses reflection rather. But JSON takes like a longer time to execute, so it's... that's going to take us... Can we finish this and then I'll answer? Okay, so retrofit plus OK HTTP. Usually, if I was going to do this, then I would use dependency injection, and I usually use Dagger, but because that was out of scope for this lesson, I tried to bring out, like create my objects manually and then show you how to use them. But I'm not going to go into modules and things, because if you're actually structuring a real world app, you need to have like a network module where you instantiate all your objects and then you inject them into the classes where you need them. But for this example, it's in Kotlin, but it's I hope we're creating a new OKHTTP object, and then we're calling the client and the builder and then the .build method. So, okay, so usually you would have like a val retrofit equals retrofit builder, but just to save space, I omitted all of that. So I'll just walk through. There are like 5 different methods we'll call before we can finish building retrofit. And we are passing in the OKHTTP client that we created from in the other slide. Okay, next we need a base URL. Usually the base URL is the main part of the URL. So if you have what's student graduate accelerator, right? So if you have like sga.com, for example, https:// so the base URL is usually the part from the H to the .com. Then maybe followed by, some people leave out the backslash, some people leave it there, but usually from the H to the .com. That's what the base URL is. And then depending on whether you need queries or whether you need additional values in that URL, you can add that later when you are creating it. And then I use this because usually in a standard app, you have production URL, you have staging URL. Like production URL is URL that real users of the app use. The staging URL is for test data, where you can play around with the app and log in and like create accounts locally that won't affect your real users. So usually it's best to keep all that value away from the main code. That's why I just put it there to show you how it's done. Now we are going to use all the factories that we mentioned earlier. So the first is the converter factory, and this is how to use it using Moshi. For the JSON one, it's not too different for all the other converters. So I'm sure that would be like JSON something factory dot create to The syntax is not exactly the same thing, but it's not too different. And then there's the call adapter factory. And this is where we import our RxJava adapter factory. It's called RxJava to call, and then you create that. Once you do this, then you can you can get your data back with observables instead of the call class. And we have the build that completes the whole thing. So before we go on, there are different annotations that you can use depending on the kind of REST request you're making, depending on the kind of API request you're making. If you're making a GET request, a POST request, then put, delete, and head. You switch up the annotations based on what you need. But I think the most common are the GET and the POST. I've really not seen a lot of people use head or delete. Even put is kind of rare. So the common ones you need are the GET and POST. So here I have a demo URL based on the name of your accelerator. And usually to work with Retrofit, you have to create an interface. People generally call it a service. So I just named mine demo service. And then we're making a GET request. Here we're assuming that you all create demos. So let's say student is in different parts of Nigeria, but we want to get the demos created by the internet for Lagos. We need the latest demo created by the internet in Lagos. So let's say that's your URL. This is the request, like this is the URL we want to get. So assuming the base URL will be the HTTP up to the .org part, and we would have stored that somewhere else. So now we're getting the latest, and then we'll input that in the GET request as a GET request parameter. And then we have a query, which is called town. So we use the @query annotation, and then enter the name of the particular query we want, that's town. And then we can now name our parameter town. We can name it something different. That's the part before the string. And then since we're using RxJava, then we're getting an observable back with a demo object. The syntax is slightly different for Java, but it means the same thing. So for Java, you would have the string. So for Java, you should have like a method. So you have a string instead of one, and then you have get latest demo, and then you just have the parameter town inside. But what this simply means is that you have a method called get latest demo. We have a query called town, and we're getting an observable with the demo object. Can I switch the slide?
Yes.
Okay. Oh, okay, so there's still one more thing here. So how do we use this demo service? We can have like our demo service because Retrofit, the Retrofit Builder thing we created earlier. So we have Retrofit.create, and then we'll pass in the name of our service class. So because this is Kotlin, we have to have the extra decoration class.java. But usually for Java classes, you don't need that extra part. You just put in the demo service, and then you can now use the demo service and query the methods inside the interface. And so we're getting into the nitty-gritty of combining Retrofit with RxJava. So hopefully, based on all the earlier explanations, this will be easier to follow. So we're using the demo service, and then since the getLatestDemo method is returning an observable, we'll call getLatestDemo, and then we'll put in Lagos since we're expecting a town. We had a town parameter from the previous method, so we can manually put in Lagos. And then since we're expecting an observable, that means that we can directly call subscribe on to switch the thread to an IO thread, and then we can call observe on to switch it back to the main thread when the results are ready. Then for error handling with the call class, it's a bit messy, but with RxJava, it's a lot easier. So all you need to do here is after observing, you now call the subscribe, because as I mentioned earlier, it won't emit anything unless there's someone, unless you like tell you what to do when you subscribe to it. So here we have we usually have two curly braces. The first contains the results we're expecting. So if you remember from the service class, we had an observable, we're expecting an observable with the demo method. So here, once you get it, all you need to retrieve directly is the demo class. Using all this, it will strip away the observable, so you don't have to interact with that. Once you're subscribing, it just gives you the class that was attached to the observable you created. You also have another parenthesis that returns the error. So this error comes back as a throwable class. So you can now decide to like print out error.message or whatever, error.localized message or whatever you want to do with the error. Or maybe take the error and then switch it to a human readable message. So sometimes from the server, you might get message not available. And then in your code, once you see that, you can now display more user-friendly message, like the operation you're trying to perform did not work out or something. And so how do we import retrofit in Gradle? Because I used Moshi as an example here, I'm going to use it here. And the classes were in Kotlin, and so I'm going to use that here. But usually it shouldn't be, even if it's Java, it shouldn't be too different from what you have here. So import Moshi, the adapters, and Kotlin, and then for retrofits, we have 3 different imports. The main retrofit, the Moshi converter. If you are using JSON, you have a converter for JSON, and then the RX Java call adapter. Wow, career section, okay. Okay, so I guess that's the end of the technical part. Do we have any questions related to this first? We'll do reflection online. We'll do reflection of, we'll take that offline, but like related to multi-threading and networking and observables and RX Java. Was there something that you have questions about that I did not cover? Or what's the scope of what you were taught?
Gone through RX Java.
Okay.
And for me as a beginner, because I just said I said October, November.
Okay.
And RX Java, I think I said to go deep. I don't know if someone from starting Android and needs to know RX Java and go in depth very well compared to, because I want to course on RX Java, so I don't really I just to get myself probably know a bit about RX Java. When I can actually work on maybe apps, but so that time when I'm working on observables, I'm always lost. I'll be like, what are these sort of things, get these, what are notations?
Okay. Wait, so which part is confusing? Using the observables, using the operators, or the part with the network request?
Okay, the annotation itself, because when my app was the annotations, I really did with gates.
Okay.
So I was like, if I don't want to do something with other annotations, how would I know what it is? I was just thinking of just going to the end. Personally, just more or less like more about it.
Okay, so if you're just starting, I don't think you need to know anything outside of everything I've mentioned here. So if I mentioned it, if it's on the slide here, then you should know it. So I tried to limit, that's why I didn't talk about all the schedulers we have. There are like 3 or 4 more, but I didn't mention them because I know that won't apply to you directly. But for post requests, so think of it this way: GET requests are for reading things from the server. You're not changing the data in any database. You just want to query and get your result back. For post requests, you are updating an online DB. So you are, let's see, what's the best way? Let's say you are changing your profile on Facebook, for example. So you are sending data back to the server. You are changing a field, you are changing a class, whatever you are changing, you are sending data back. That uses a post request. But for GET will just be like, fetch data, display it to me. You know, you're not changing anything. I think that's the best of position. To be honest, I've not really used head. I think delete is to delete like a particular class from, so maybe you send the class along and then you want to delete that file in your online record. I'm not too sure because I've not even used that a lot. Then I'm not sure what head does. Put is like, I think put is a form of post. This is recorded, so I have to be sure what I'm saying. I think put is a form of post, but usually the main ones you have to use is get and post. And once you know that get is for fetching data without modifying it, post is for modifying data, then I think you are good for now. And then when you have more experience, then you can decide to explore more.
I think that is for using metadata of this.
Yeah, probably. I've never even had to use it, and I've been doing this for like 4 years. So you rarely see API requests that require you to use head. Any other? Related to this, have you tried requests that didn't work? Or I tried to stick with the scope of, I know RX Java is like a 1 month course on its own, so I didn't bother going there. I just picked the parts that I thought would be relevant. But if you're like aiming to go deep into RX Java, there are all sorts of operations, maps, switch maps, concats. Yeah, there are different operations, and that's another section that's been. But I assume that since you already had the intro with Mayowa, you would have had at least understood what observables are, what subscribers are, and then I was going to build on that. Well, it looks like you're all good. But was it okay? No, I think you need a color adapter with RX too. But because I usually just avoid, because there's no point since. No, wait, with RX, no, you don't need a color adapter with RX Java. That's the whole point of using RX for retrofits. So if you're using retrofit without a converter factory, without a call converter factory, then you have to use all the call class and everything. Oh, wait, am I getting this right? Yeah, you have to use the call class, but with RX, you don't need, you can just work with the observables directly. Well, how do you normally do it? Okay, but okay, so I think you should switch to 2. There might even be 3 coming in the future. Yeah. Yeah, so I don't think there'll be too many breaking changes, but at least if you have the basics of this, it's best to switch. At least leave 1. I think with 2, the main things are the no, not flow, the back pressure support. I don't remember what it's called. Yeah, flowables. That's what I was trying to remember. That's the main thing that came with 2. So I don't think there'll be too many, because as they're building this, they won't want like developers to have to do too much work to update their code. Okay, I'm not sure how much time was spent, but I'm just going to move on to carrier section. This part might seem trivial, but it's actually important if you are looking to work locally and internationally. Employers look for a lot of things, and sometimes because you are in this local market, you might not know if your current employers don't ask you for it. So the first thing, of course, is the technical experience for the role. Some companies will want you to do a coding challenge as part of the interview process. So like algorithm questions that have nothing to do with Android on HackerRank or LeetCode, or make you pair programming Google Docs, where you'll be writing code without your compiler. And then some people might have take-home assignments. They'll give you an Android app, tell you not to spend more than 6 hours on it, and then you send your code back. Some people might give you an Android challenge, but timed in some platforms. So you have to write the code and time is ticking. And then once your time is up, you can't access it again. Some people will ask you, some people will have a call with you and then just discuss your Android knowledge. And based on the conversation, they can depict what level you are based on your fluency and how much you can talk and how much you know about what they mentioned. And then sometimes they are like behavioral interviews where they just want to get to know what it's like working with you. So they'll ask you questions to ask for exactly what you did in your previous roles, what your contribution was, if you've ever tackled challenges, how you handled it, and all those other questions, just to see if they would like working with you. But I think this part is also very important, soft skills. People call, I don't know why it's called soft, because they're actually important. I think they should be people skills. I think I saw that on Twitter once. They should be called people skills because, yeah, as much as you're writing code in your ID, you're also interacting with a lot of people at work, and you need to be able to work with people and know how to relate to people. That won't result in arguments and fights every 2 seconds. You need to be able to learn how to, I think, be diplomatic, how to craft your tone for business environments, how to leave feedback for people, just generally how to work with people and not piss them off every second. And then growth potential. So usually, sometimes some companies are not looking for someone who knows everything. They are looking for someone who knows at least the basics, but is teachable. So they know, like, if we hire this person doesn't know this, but we can work with them. That's the people skills, and they seem like they have potential to grow. So to even show this, you need to show that you, on your own, you go out of your way to look for knowledge. So they might ask you, how do you keep up with the Android ecosystem, for example? And then when you mention things like you read newsletters, or you watch videos from conferences, they need to know that you are showing signs that you can learn on your own and you are teachable. Because if they bring you in and you don't have the skills, then they know that at least they can help you grow to fill in the role. So writing skills, this is very important, most especially if you are going to work remotely, because most of the communication will not be done in person. And then depending on your time zone, you might not even always be able to have face-to-face meetings. Sometimes you do something and then someone wakes up in a time zone 8 hours later to check, and then that one goes to sleep, you wake up to check. So you're never in sync, and your writing skills will always come into play here. And so contributions to the community, this is not necessary, it's not required, but it's important. It kind of, first of all, it helps you grow your reputation, especially if you come from a place like this where people generally won't know who you are, but they can reference what you've done online. So if you write articles, you have side projects on GitHub, you speak at events, let's say you're applying to a remote role to a company in, what's the most remote place you can think about? Yeah, so Finland, for example. And then they're like, who is this person? We don't know who they are, but they applied and they want to give you a chance. So they are going to Google you, of course. And then if they do that, if you have this track record of contributing to the community, it sort of helps build it gives them confidence that at least you're in this space and you know what you're doing. You still have to pass the interviews, it's not just that, but it just helps you, gives you a better score than some random person they can't even find any trace of Android knowledge about online. So it's not required. Nobody will mandate you to write articles or contribute to society or anything, but it helps your visibility. But also, contributing is a great way to learn. So for me to give this talk, I had this RX Java book that was like this, I think, Intro to RX Java. I had to read articles. I read a lot of material, more advanced than this. And then I had to think of the best way to distill it, to make it simple enough for people who are just beginning to understand and not get lost in. So all that now, nobody can take that knowledge away from me. And all that is going to help me in work just because I decided to do some research to help bring some other people up. So teaching is a great way to learn, and then it helps your visibility, it helps your community profile. So how to build a career portfolio? How do you get started with these things. Like if you don't have any trace at all, you can contribute to an existing project, although for a beginner that might be overwhelming. So for example, if you find a bug in RxJava, you can go to their GitHub and then create a pull request and send it in, and then if they like it, they approve it and merge it. That's one way to do that. Another way is to upload code snippets or sample apps to GitHub. So say when I was creating this, I created some apps to actually test my upstream claim that subscribe on works upstream. So if I have a sample app that I have a couple of methods and I just want to test, I can decide to upload that to GitHub as a GitHub gist or maybe a small sample app. Or I can create a small app to show how to use navigation components, or a small app to show how to use Dagger. Just all the small things, just upload them. It doesn't have to be full things. You can have real full apps that you publish to Google Play. And this doesn't necessarily have to be your own personal app. If you work at a company and you are in charge of like working on the Android app, just make sure that you know how to publish the app, like you're in charge of publishing, or you know how to, because you can also reference this and in an interview say that you worked with social company and you maybe sent out updates there to Google Play, or you had the sample app that you published. And then usually a common Android question, I've not seen it recently, but sometimes when you say you're an Android dev, they tell you, give us links to app you've published on Google Play. And then sometimes that's where these side projects come into play, because then you have something else to reference that you can upload that not necessarily companies work. And so writing technical articles, like I said, writing is a good way to learn, because you're teaching others and then you have to be sure that everything you're saying is correct. And in some instances, I found that articles I wrote online that was supposed to help explain something to people, a couple of months later, I was running into the same issue and I Googled and my article was the first one that came up. So it was like I was writing to my future self to save me from the same problem again. And then, writing helps with, so if you want to become a GD, they look at your community contributions, articles, talks. Writing is also a great way to get on that track. Yes, give talks. You don't have to, a common problem people have is that they think that they have nothing to talk about, but this is usually not true. If you learn something new at work, or you come across a bug that was difficult to solve, or a new technology came out at Google I/O and you just explored it, you can go into, for talks, you have to be a bit more detailed, like you have to go in depth a little bit more than an article, because for a talk, you can get like 20 minutes for lightning talks or 40 minutes for a full talk. So you have to do a little bit of more research than you do when writing an article, because you're going to be speaking for so long. But then it's also a great way to help your visibility. Also, conferences help you. Conferences for me are not even about the talks. I can always get the talks on YouTube. They're about the people I go to connect with in real life that I won't have access to, because you randomly won't be able to gather like all the top developers from a place and maybe Google developer advocates. So imagine like meeting Florina and Ben and all those people. Usually, the only way you usually get to meet all of them is at a conference. And that's the way they can connect and then relate and say, oh, hey, I saw your article. Yeah, the person that wrote this article, I've been seeing your name online. It's nice to meet you in person. And then building these face-to-face connections help go a long way for when they actually matter. All right, so how to find opportunities? Social media. LinkedIn is, well, I should have put Twitter before LinkedIn. Because if you know how to use Twitter, then there's a great connecting potential on there. And like I said, if you want to start your portfolio, Twitter helps to kind of build a brand. And people can tend to know you and associate you with something. I'm sure if I've not met you before, most of what you know about me is from Twitter. Most likely going to be from Twitter. And then you can add this stuff to your bio, and if you write articles or you give talks, you share links to your slides, and gradually you gain a following. People kind of tend to associate you with Android. And if you keep putting out quality content over time, it might not necessarily fetch you a pay increase, But say if you are looking for a new job, for example, and you put it out there, people will be like, hey, I know this guy, he writes a lot of articles that I've read that are good. Maybe we should give him a chance. Or even if they don't have any roles open, they can recommend you to somebody or sort of connect you. You never know how these things work. But if you want to like build a following and everything, you should think Twitter, maybe LinkedIn. And sometimes people post job opportunities on Twitter. Some companies post, or the employees themselves. You see a lot on LinkedIn. So there's a LinkedIn section where you can search for jobs, and the recruiters also reach out to you directly. So I think now you can set a way to say you are looking for a new job, and then set what location you are looking in, whether you are available immediately, and then recruiters have a way of seeing these things, and they reach out to you directly. You can also use Stack Overflow jobs. Well, that's usually for jobs outside of Nigeria. I think LinkedIn works and Twitter works for within Nigeria. Twitter also works for outside, depending on who you're following and where you're looking. Newsletters, Follow has a section for jobs. Then there's Android Weekly. They have a section, even on their websites. I think it's androidweekly.net/jobs, where you find all sorts of job postings. There's also the Kotlin Weekly that advertises jobs too sometimes. Then job search marketplaces, Hire.com, Fiverr, Upwork. I usually won't use any of these, but they are available to try out if. Well, for me, they are too abstract. I like an opening where I can, like, there's a human element at some point. I'm not sure how Hired or Fiverr or Upwork, like, I'm not sure how they vet your files or anything, or how they decide to invite you for an interview. Or I'm not sure how it works, but I feel like if I go through Stack Overflow jobs, then, and I submit my application to, let's say, a company's website, then if a machine doesn't vet it, it's not like Stack Overflow jobs are the real deal or anything. But if a machine doesn't vet it, then maybe a recruiter would take a look at it or something. But these are all the first aspects. But the tried and true aspect I'm going to talk about is like not even just company career pages. Sometimes companies list jobs on their website. So if you want to work at some company, you can just go to their careers pages and see, like, let's say Google, what jobs are available at Google? Oh, there's an Android role, I'm going to apply. But usually it's best to find someone in that company that can recommend you or get your CV in or +1 you somehow. It works for two of you, because usually if they recommend you, they get a bonus. They get paid if you eventually pass all the interviews and get hired. So they get a bonus. So I'm sure they will be happy to vouch for you if they know you already. So if you want to work at Google, for example, you can apply through the Google's website, but it's better if you find like a recruiter to reach out to, or some employee of Google that you can ask directly if they can forward your CV or like make a case for you internally so that your application gets in. And usually this is almost how like work employment happens. By the time the thing goes to their website or to the other job portals, then like maybe they didn't find people to get directly, because usually they will tell. I've had people reach out to me that, hey, I'm hiring for this role, are you interested? Before the job even appears anywhere online. So by the time you're applying to Stack Overflow jobs and Twitter, it might be like maybe they tried reaching people directly and they didn't find, or maybe like they're in the process of getting a, but it's usually best to go through someone you know. I'm going to mention something else. Can't remember. Yeah, so questions about career.